Hi everybody, welcome back. I'm sure you've missed the videos. This is our second unit in our first video. So this is unit 2, lesson 1. And we're going to talk about what makes up matter. So we talked about different types of matter. We talked about how we measure matter, how we classify it, changes in matter, and energy changes associated with that. And now we have to talk about what, if we could look at matter with our Miss Frizzle glasses, what it's composed of. And how our ideas about what it's composed of have changed over time or evolved over time. So, back in the day of the early Greeks, long time ago, there were two really kind of dueling schools of thought. There was Aristotle and there was Democritus. And Aristotle argued that all matter is made of the elements earth, air, fire, and water. And that was really his argument, was that all matter is made of 4 fundamental elements, and those elements were earth, air, fire, and water. So not elements like on our periodic table. These were elements that he thought everything is composed of some combination of those 4 things. And another school of thought was Democritus. And Democritus thought that matter was made of smaller, indivisible particles called atomos. Indivisible means cannot be divided. Shh. Okay? So he thought of no parts to atoms, just think of atoms like hard spheres. So he thought that atoms were made of smaller particles. Those particles were very similar to hard spheres. Okay? And unfortunately, at the time, what people accepted and what people believed in was the popular opinion. And Aristotle was a lot more popular than Democritus and had a lot of influence. So his ideas were more widely accepted than Democritus's ideas. Okay? And Aristotle had a little argument. He said that, if you have a piece of wood and you burn it, you release the fire inside of it. And that fire turns into air. And then the wood turns to dust, which goes back to the earth. And so, due to the fact that Aristotle was more widely accepted, he had a better political opinion, nobody really piggybacked off Democritus' ideas, and we went with this these idea of earth, air, fire, and water. Okay, so those were his early ideas at the time. To give you a little perspective on atoms and size and parts of atoms.
They are the fundamental building blocks of all matter.
I think we'll watch this little video from Bill Nye the Science Guy, because who doesn't love Bill Nye the Science Guy? Everybody loves him. So we're just going to watch this small video, and what I'd like you to do is, on a separate sheet of paper that you will turn in tomorrow, I would like you to record 4 facts about atoms that you hear on the video. He gives you a great perspective about the size of atoms on this video. So here we go.
So, if we could somehow control the market on these things, just think of the possibilities.
Sir, you're talking about
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. See you on next science.
Bill Nye the Science Guy.
Brought to you by Elements, building your world one atom at a time.
This door, this tie, this keypad, and this guy are all things. And things are made of stuff. Tiny pieces of stuff.
Run!
No, I mean tiny pieces of stuff. Much tinier than you can see with the human eye. Now look around and count how many different things there are. Yeah, count everything. There's tires and tools. There's kids and cows. There's wood. And there's horse. There's fish in the sea. There's stars in the sky. There's even kitchen sinks. You can count thousands, millions, billions of things. You call all of this stuff matter. It turns out that if we break matter down, take it completely apart, all of these things are made of just a few things. Imagine cutting a piece of cheese in half. Then, in half again. And in half again. And 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 again. Eventually, you'd end up with a piece too small to cut. There'd be no knife sharp enough. The tiny, tiny pieces that couldn't be broken apart any farther. They'd be unbreak-apartable. We call them atoms. That's from a Greek word that means uncuttable. Atoms are too small to see, even with a regular microscope like this. Here is a model, a first look at an atom. Now here are the main parts. Well, they're particles. Particles, get it? Anyway, in the middle are very heavy particles. And buzzing around the middle are very light particles. Now, if we could see an atom, it couldn't look anything like this because atoms are mostly empty. Take a look at this. It's our proper proportion giant atom model of science. Now, this part isn't very giant. That's because it's just the nucleus, the middle of an atom. Now, in here are two kinds of particles, protons and neutrons. No one knows what they would really look like. The protons have a positive electrical charge, like a spark, and the neutrons have no charge. They're neutral. They just hang out in the nucleus. Now, buzzing around the outside of the nucleus are very small particles called electrons. Maybe you've heard of them. In fact, the flow of electrons from one atom to another is called electricity. If this vibrating, buzzing ball is the nucleus of an atom, how far away do you think the electron would be? Well, as far as you could jump? No. As far as you could throw a ball? As far as you could run? Well, yeah. Take a look. You can see it from here. It's way out there.
It's yummy.
The electron would be here. 500 meters. 5 soccer fields from the nucleus. So, everything that's made of atoms, everything that you can touch and feel, is mostly empty space. Empty space. Empty space. Empty space! Now, the electron weighs, a 10,000th of those particles in the middle. And it's going around so fast that it's only here now and then. It's here, and then here, and then I gotta go. And that.
All right, so that's all we're going to record in our notes for today. There will be another video tomorrow. We talk more about how what we know has evolved, right? We're still in the early Greeks, and Bill Nye gave you a really good idea about the space difference in an atom and some of the parts. So come with that tomorrow, and we'll go over our test. Have a great night, everybody. Bye-bye.